You are standing at the edge of a hedge in late summer. The air smells like warm dust and crushed leaves. In front of you, half hidden behind a curtain of green, there is a berry. It is glossy black, about the size of a small cherry, sitting in a little star-shaped collar of leaves. It looks clean. It looks ripe. Every instinct you have for finding food says yes, and if you ate 3 of them, you could be dead before morning. That plant is a Tropa belladonna, deadly nightshade. Carl Linnaeus gave it that name in 1753, and he chose it deliberately. Atropos was the eldest of the 3 fates in Greek myth, the one who cut the thread of a human life. The berries contain atropine, hyoscyamine, and scopolamine, and as few as 2 to 5 are considered a fatal dose for a small child. Here is the part that should disturb you. The berries are not bitter. People who have survived eating them consistently describe the taste as sweet. Your entire body is equipped with an ancient chemical alarm system built to stop you from swallowing poison, and this particular plant walks straight past it. For roughly 2 million years, your ancestors had no laboratory, no label, no ingredient list. They had a mouth and a guess. What happened when they guessed wrong did not just kill individuals. It rewired the species. By the end of this, you will understand why you flinch at black coffee, why children refuse broccoli, and why a bitter taste on your tongue is really a warning message from people who died 40,000 years ago. Start with the size of the problem. There are around 391,000 known species of vascular plants on Earth. A plant cannot run, hide, or fight back, so it defends itself the only way it can, chemically. Botanists estimate plants produce over 200,000 distinct secondary metabolites, compounds that serve no purpose in growth and exist largely to poison whatever tries to eat. Cyanide in apple seeds and cherry pits, solanine in green potatoes, oxalates in rhubarb leaves. Your ancestors were not walking through a garden. They were walking through a chemistry set, and everything in it was trying to kill them. So evolution built a filter. You have exactly one functional receptor system for detecting sweetness. 1. You have roughly 25 separate working genes dedicated to detecting bitterness, a family called TAS2R. Think about that ratio for a moment. Your body invested 25 times more genetic hardware into detecting danger than into detecting reward. That is not a taste preference. That is a security system, and it was paid for in bodies. In 1931, a chemist named Arthur Fox was working at the DuPont laboratories in Wilmington, Delaware. He was transferring a powdered compound called phenylthiocarbamide when some of it escaped into the air. A colleague standing nearby, Carl Noller, complained immediately that the dust tasted intensely bitter. Fox was standing closer to the spill and tasted absolutely nothing. The 2 men argued about it, then did what scientists do. They started testing everyone they could find. Fox tested his family, then colleagues, then strangers. The result held. Around 70 to 75% of people taste phenylthiocarbamide as overwhelmingly bitter. The remaining 25 to 30% taste water. In 2003, a team led by Eun-Kyung Kim identified the gene responsible TAS2R38, sitting on chromosome 7. 3 tiny variations in that single gene determine whether an entire category of compounds registers in your mouth as a threat or as nothing at all, which means the human species is split right now into 2 populations with different poison detectors. And that split is not random. It is a fossil of something that happened while your ancestors were eating. In 2004, geneticists made an uncomfortable discovery about TAS2R38. They sequenced the gene in chimpanzees and found the same split, some tasters, some non-tasters. For decades, this was read as proof that the trait was ancient and shared, inherited from a common ancestor around 6 million years ago. Then, in 2006, a team at Cornell, led by Stephen Wooding, sequenced it properly. The chimpanzee non-tasters carried a completely different mutation, at a completely different position in the gene. 2 separate species had independently evolved a broken poison detector. Evolution does not usually do the same expensive thing twice by accident. When a trait appears twice, in parallel, and survives, it is because it was worth something. Which raises a genuinely strange question. What survival advantage could there possibly be in being worse at detecting poison? The answer is that bitterness is not a reliable signal. It is a rough approximation, and it is wrong constantly in both directions. Deadly nightshade is sweet, and it will stop your heart. Meanwhile, the compounds that make broccoli, kale, cabbage, and Brussels sprouts taste harsh are glucosinolates, the same family as phenylthiocarbamide, and they are associated with reduced cancer risk. A hunter-gatherer who rejected every bitter thing would starve in a lean season while standing on top of edible roots. A hunter-gatherer who accepted everything sweet would eventually find belladonna. Neither strategy wins outright, so the population hedged. Some of you are hypersensitive detectors, and some of you are not, and the group survives conditions that would eliminate either type alone. But detection was never going to be enough on its own, because some of the most valuable food on Earth is lethal no matter what your tongue tells you. Consider cassava. It is a starchy root native to South America, and today it feeds an estimated 800 million people across the tropic. Raw bitter cassava contains linamarin, a compound that releases hydrogen cyanide when the plant tissue is damaged. A single unprocessed meal can be fatal. Chronic low-level exposure causes konzo, an irreversible paralytic disease of the legs, first formally described in 1938 in what is now the Democratic Republic of the Congo. By any sensible logic, this plant should have been abandoned thousands of years ago. Instead, indigenous peoples in the Amazon built a machine to defeat it. The tapiti is a long, woven tube of palm fiber, sometimes 2 meters in length. Grated cassava pulp is packed inside. The tube is hung from a beam, and a lever is used to stretch it. As it stretches, it narrows, squeezing the toxic liquid out of the mash. The pulp is then washed, soaked, fermented, and finally roasted. Anthropologist Joseph Henrich has pointed out the critical detail about this process. No single step is obviously necessary. The processed and unprocessed root both taste fine after cooking, and the effects of failure paralysis, illness can take months or years to appear. Nobody could have discovered this sequence by tasting or by reasoning it out in one lifetime. The knowledge is older than any of the people using it. It was assembled across generations, by trial and by watching the people who got it wrong, which tells you exactly how these techniques were paid for. The pattern repeats everywhere humans settled. In California, acorns from oak species are loaded with tannins that are astringent enough to make them inedible and damaging to the kidneys in quantity. Indigenous Californian peoples, among them the Miwok, Pomo, and Yokuts, developed leaching methods that involved grinding the acorns into flour, spreading it in a shallow sand basin, and pouring water through it repeatedly, sometimes for hours. Acorns became one of the primary food staples of the region. In the Arctic, Inuit communities avoided fatal vitamin A poisoning by never eating polar bear liver, which can contain concentrations high enough to cause the skin to peel from the body. In Japan, the preparation of fugu remains so dangerous that chefs still require years of training and a license. These are not recipes. They are survival protocols, written in a language no one alive was around to hear composed. But there is one more thing your ancestors did with poison, and it is the strangest turn in the entire story. Some of them stopped trying to avoid it. In 1991, 2 hikers in the Ötztal Alps, on the border between Austria and Italy, found a body frozen in the ice at 3,210 meters. He had died around 3,300 BCE, and he is now known as Ötzi. Among his possessions were 2 lumps of birch polypore fungus, threaded onto leather straps. Researchers noted the fungus contains compounds with antibacterial and antiparasitic properties. Ötzi's intestines were later found to contain the eggs of Trichuris trichura, whipworm, a man carrying a specific toxin in a specific quantity against a specific parasite. This is the discovery that changes the shape of the story. Poison and medicine are the same category of substance. The only variable is the dose. Look at what the deadly plants became. Atropine from the same deadly nightshade in that hedge is on the World Health Organization's list of essential medicines. It is used to treat bradycardia and to reverse poisoning from nerve agents and organophosphates. Ophthalmologists still use it to dilate the pupil, exactly as Renaissance Venetian women once did cosmetically, which is where the name belladonna, beautiful woman, comes from. Digitalis, extracted from foxglove, was described medically by the English physician William Withering in 1785 after he investigated a folk remedy used by an old woman in Shropshire. Foxglove will stop a heart. In a controlled dose, it steadies one. Willow bark, chewed for pain across multiple ancient cultures and referenced in Egyptian medical texts, contains salicin. In 1897, Felix Hoffmann at Bayer produced a stable, modified version of it. That compound is aspirin, and roughly 40,000 tons of it are consumed every year. Every one of those substances entered human knowledge the same way. Somebody ate something they should not have, and somebody else was watching closely enough to remember what happened next. So return to the hedge. You are standing in front of a black berry, and you do not eat it. You feel no particular pull toward it, and no particular fear. You simply move past. But notice what actually happened in your mouth this morning. Coffee is bitter and you drank it anyway. Dark chocolate contains theobromine, a compound toxic enough to kill a dog, and you have overridden every warning your tongue sends about it. You have taught yourself, in a single lifetime, to enjoy the exact signal your ancestors used to detect death. That is only possible because the question was already settled. Somewhere behind you, in an unmarked stretch of deep time, a person picked up something glossy and sweet, and did not survive the afternoon. And someone standing nearby looked at the plant, looked at the body, and understood. You did not inherit their memory. You inherited the conclusion. Every meal you have ever eaten was pre-tested, thousands of years before you were born, by people who did not know they were running the experiment.